Okay, I'm going to have a look at some Year 9 revision for Term 4. This is what my Year 9s are working on, and we have an end of semester exam, so that's why I've got quite a number of topics that we are looking through in our revision. So just going through what we are revising, and I will break this into several videos, so know that have a look for the rest of them in the playlist for Year 9 Term 4 revision. So we've got linear equations. We need to know our y equals mx plus c, and we need to know that our gradient is y2 minus y1 over x2 minus x1. So we need to be able to use that and find gradients, find equations of lines. We need to be able to simplify indices using our index laws, so that's back to our Term 3 work there. We need to be able to identify or prove similar triangles, and also find scale factors, and also find missing values on our similar triangles. We need to be able to expand brackets. We also need to be able to factorise. With our expanding, we need to be able to do one set of bracket, two sets of bracket, and the patterns like difference of two squares and perfect squares. For percentages, we need to be able to increase by a percentage, decrease by a percentage, work out profit, work out loss, percentage profit and loss with those. And we also, when we were doing our percentages, touched on a bit of income and looking at tax with that, the percentage, working out percentages, so basically an application of our percentage work there. We also looked at simple interest, so you need to know your I equals PRT. Some teachers may use I equals PIN. I like to keep the separation between the simple interest formula and the compound interest one, so I use I equals PRT and A equals P plus I for that. For my compound interest formula, then I use A equals P outside of 1 plus I to the n. So that way I can keep them as separate and not have any overlapping features. We also need to be able to collect like terms and simplify expressions. We need to be able to solve equations. So I'm going to start going through some types of questions that relate to each of these topics. So the first one that I am starting with is that I want to be able to state the gradient and y-intercept of an equation that I see. So when I see this, I'm thinking about my y equals mx plus c. So I'm looking at this equation that I've got a -3 as my gradient, and my y-intercept is -5. So my M means gradient, my C means y-intercept, and I can identify that in my equation and state what those are. I also need to be able to find the equation joining two points on a line. So when I do that, my first step is to use my gradient rule. M equals y2 minus y1 over x2 minus x1. I'm putting that into, so I'm going to write my x1, y1, x2, y2 up the top here. So now I'm going to go 7, take away 5, over 3, take away 1, and so I get 2 over 2 there, which is 1. So my gradient is 1 in this case. Obviously you'll have seen some that have a negative gradient, a fraction for a gradient, a decimal, lots of different variations. This one's a fairly straightforward one, so we've got a gradient of 1. And now we're going to solve for our C in our y equals mx plus c. So we've got the gradient and we're going to solve for c. So I'm going to write my y equals mx plus c over here, and I've got a gradient of 1, and then I choose one of those coordinates to use for this part of the question. So I'm going to choose the 1, 5. I could have chosen the 3, 7, and both will work. So my x is 1, my y is 5. So I'm going to write 5 is equal to, my gradient is 1 times 1, because my x value was 1, plus c. 1 times 1 is 2. So I can say that c must be equal to 3. 2 plus 3 will give me 5. So my equation is y equals x plus 3. I want to then check that over here to make sure I've worked it out right. So if I put that into my equation, when I have got my down here, y equals x plus 3, if I put in my 3 there, 3 plus 3 should give me 7, which it does not. So tracking back, what have I done here? Done my 1 times 1. And now I can see what my error is. 1 times 1 does not equal 2. 1 times 1 is equal to 1. So then I can come back here and go, okay, I've found my error. 1 times 1 is 1. That means my C must be 4. I come down here and I get an x plus 4. So this is a very valuable lesson to learn when you're doing your exam. So always do that little check at the end. That's where I found my error. And then I could go back and double check that. So then I go to that first coordinate, x plus 4. 1 plus 4 is 5. Yes, it works for that coordinate. Does it work here? 3 plus 4 is 7. Yes, it does. So I've got my equation. So always do that little check at the end. Then we have our simplifying. So when we've got our simplifying, we've got our brackets. So we need to do that part first. So I'm going to disregard this 9x squared and just apply the squared from outside the brackets to each of the things inside the brackets. So I'm going to get 9x squared, and I'm multiplying that by x squared, and my y will be y to the power of 6. Now I've got my 9 will stay as it is. X squared times x squared is x to the power of 4, y to the power of 6. Then I've got one where I'm collecting my like terms. So I've got 5xy minus 3xy. That's going to give me 2xy. Then I've got minus 3x squared plus 5x squared is plus 2x squared plus 2y. And that is my simplified expression. Now I'm going to do a solving question because there's another one that we need to be able to do. So I'm going to expand this bracket out first. 7 times x is 7x. 7 times 3 is 21. Then I will do 49 take 21 is 28. So my x is going to be equal to 4. The other option here is to divide by 7 on both sides first, and that would give you x plus 3 is equal to 7. So x is equal to 4. That's another option there when you have a brackets. Looking at my next type with solving, I have variables on both sides. Now, when we do that, we do have different options that we can still get the same answer, different orders that we can do it in. So looking along my line, I've got my 3x and my 2x. I look for which one is the smaller, and I'll take that over to be with the bigger. Look at these two numbers and take that over that way. I could have taken away 8 first, or taken away 5 first, or taken away 2x, or taken away 3x. So I've got 4 options. I'm going to start this one by taking away 2x. So I'm going to get the x's together. So I have x plus 5 equals 8. And then I'm going to take away 5, and I'll get x is equal to 3. So like I said, we could have taken away the 5 first, and that would have given us 3x equals 2x plus 3, then taken 2x, or we could have taken away the 8 and got a 3x take away 3 is equal to 2x and go that way. Lots of different options. Here we've got our expanding, so we're going to do 7 times x and 7 times 4. We're going to do 5 times 3 and 5 times minus 2x. So we've got 7 times x plus 7 times 4, plus 5 times 3 plus 5 times negative 2x. So we get 7x plus 28 plus 15, and then we've got 5 times negative 2x will be minus 10x. So now we've got 7x take 10x is going to be minus 3x, and we've got 28 plus 15 is going to be, 28 plus 15 will be 43. Then we have our r plus 7 all squared. We've got 2 options here. We can write it the long way, or we can use the pattern. So using the pattern, we would have r squared, and then on the end we would have 7 squared, which is 49, and in the middle we would have 2 times r times 7, which is 14r. That's using our perfect square pattern. Otherwise, coming over to this one, we would be doing our smiley face expansion. So we would do r times r is r squared, plus 7 times 7 is 49, plus 7 times r is 7r, plus r times 7 is 7r, and we get r squared. We bring these two together, plus 14r plus 49. Here we've got our difference of two squares. So we know when we see a plus and a minus and we have the same two things in each bracket, that means we can go straight to r squared take 5 squared, which is r squared take 25. If we didn't remember that, we could do it the long way, and we would go r times r is r squared, 5 times minus 5 is minus 25. Then we've got r times 5 is minus 5r, and 5 times r is 5r, and we can see we get the minus 5r plus 5r, they cancel out, and we're left with the r squared minus 25. Then we have our 2a plus 3, and we're multiplying that by times 8 minus 4. So we're going to go our 2a times a plus 3 times minus 4 plus 3 times a plus 2a times minus 4. So we get 2a squared take 12 plus 3a plus, minus 8a. And then we get 2a squared. We've got plus 3a take 8a is minus 5a minus 12 as our answer. Now I'm going to stop the video here because I'm then going to go on to some factorising just to keep our videos not too long.